All right, let's get reviewing for this quiz. The first couple of problems on the quiz will be like this. You do have to know some things. You will be given a unit circle, but the unit circle doesn't always tell you the full story. The first question, they're just looking for what angle has a sine that's radical 2 over 2. So you can put this in degrees or radians. It doesn't really specify, so that would be 45 degrees, or you could call that thing pi over 4. Now, whenever you have the cosine and the inverse cosine, or the tangent and the inverse tangent, they generally cancel. But you do have to keep in mind that the number that they give you isn't always going to work. That one works. This one will also work for tangent, arctangent. All right, so we're good there. This one, the sine of the arcsine. Now we got to be careful with this one. So inverse sine rather, only lives between here and here. So negative 3 pi over 2 is actually asking you to go all the way around, which we're not allowed to do. So we need to come up with, oops, sorry, I went the wrong way. We still can't do it, but let me draw this correctly. So it's asking you to go this way. So that's what it's asking you to do. So we're in the correct spot. This is the correct spot. We're allowed to be here, but we just have to come up with a different name. This is really pi over 2. So really, they do cancel, but the problem is we're not allowed to use that name. So we have to come up with a name, another name for that exact same location. Same thing happens here. This one's different. See how the cosine's on the outside? When the cosine's on the outside, anything goes. It's when the inverse is on the outside, we have to really pay attention. So for this one, the cosine of 11 pi over 6, 11 pi over 6 is over here, and cosine is not allowed to be there. Cosine is only allowed to be here or here. But we know that all scholars take calculus. We know that cosine's positive there. So we have to come up with another location where the cosine is positive. So that's, of course, right here. So what's the name of that angle in the first quadrant? Well, that's pi over 6. So it's just going to be pi over 6. Now, when there's two different words, it's actually sometimes a little bit easier. So just you look at the unit circle, and we start here. What is the cosine of pi over 3? Remember, on the unit circle, every point goes cosine sine. So we're looking for the x value at pi over 3. That's 1/2. And then the question is, what angle has a sine that's 1/2? And that, of course, is pi over 6. So again, start here. What is the sine of 2 pi? All right, so remember, I don't know what I'm trying to do there. The sine of 2 pi, is actually 0. And the question now says arctangent. So what angle has a tangent of 0? Now there's two locations that have a tangent of 0, here and here, right? So this and this spot. But tangent is not allowed over here, arctangent I should say. So that means we have to just go with 0. This question, again, we start here. What angle has a cosine of radical 3 over 2? Well, that's pi over 6. And then you just bring that word down. So what is the sine of pi over 6? 1/2. You'll need the unit circle to answer these questions as well. And I will give you one on the when you come in for the quiz. So the first thing we have to do here is, of course, add the 1. We want it to be word equals number. So we'll divide by 2, get all these numbers together. So the sine squared of x is equal to 1/2. Now we take the square root. And of course you get a radical 2 on the bottom, so you got to fix it. The problem is the unit circle has everything rationalized, so there's no radicals in the denominator. So if you wanted to match the unit circle, you have to go through that little bit of rationalizing to get that radical out of the denominator. So we took the square root, so that's plus or minus radical 2. These are all the pi over 4s. So since it's positive and negative, you have to give an answer for each quadrant, and we're going to just follow that pi over 4 family and just write down all the pi over 4s. So here we will add 7. So negative 6 cosecant equals 12 and divide by negative 6. So we have the cosecant is equal to negative 2. Well, we don't really do cosecant. It's not on the unit circle, but we're going to basically take the reciprocal of both sides. 1 over cosecant is true, but we don't really want to use that name. The better name for it is the sine, and over here we give negative 1/2. So now the question is, what angles have a sine of negative 1/2? If you're trying not to search and spend a lot of time searching, remember this. So sine is negative in those two quadrants, and so this will be 7 pi over 6 and 11 pi over 6. Number 11, we don't have to do anything to. We can just go ahead and take the square root. So we know that the tangent of x is equal to plus or minus radical of 3. Well, when we did tangents, because tangent's not on the unit circle, I gave you a little trick to remember tangent, just because it's difficult to do. So if you have, I don't know if you remember this, first quadrant, the ones right down the middle, those are, the tangent is 1. At pi over 6 and pi over 3, we have a nice pattern. If it's pi over 3, it's just radical 3. And if it's pi over 6, then we need 2 3's. So that would be radical 3 over 3. So this has only 1 3 in it, so we know it's pi over 3. So now we know what angles to look for. So if you don't know those names, that's no problem. Since it's plus or minus, we have to use all 4 quadrants. So we're going to do pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now we just switch to degrees. And also you can see the questions are different. Round to the nearest tenth. This means you'll need your calculator. So these might be on the unit circle, but chances are good they won't be. So you'll need to have a calculator, and we'll put these in the calculator. The process is the same. We want it to be word equals number. So 6 cosine x is equal to 5, and then we divide by 6. So we know that the cosine of x is equal to 5 over 6. Now when you use the calculator, you have more work to do. Just the way it goes. In the calculator, you do second cosine, and then that'll show up like this, cosine negative 1. And then you just put in 5 divided by 6. You don't have to use any fraction keys, just use the division. And you will get, out of the calculator, 33.6 degrees, because we're going to the nearest tenth. But of course, there's more than one answer. Cosine is also positive right here. So you're going to have to know that in order to get it into the fourth quadrant, we have to do 360 minus that angle we just calculated. And so the other answer is 326.4 degrees. So let's get this one set up. 3 tangent of x equals 12. And now the tangent of x equals 4. So the process is the same. Second, tangent 4, and you'll get 76 degrees. And now we have to go, okay, well, where else is the tangent positive? Well, right here. In that quadrant, we do 180 plus your angle. So 76 plus 180 is 256 degrees. Setting this last one up here. Negative 2 cosecant x equals 3, and we divide by negative 2. So we do not have a cosecant button. So we're going to have to flip this over, basically do the reciprocal. So 1 over cosecant is the sine, and then flip this other side over, keep the negative sign, and then, so now we're going to type in the calculator second sine, negative 2/3. And when you get out of the calculator, you get negative 41.8. We don't want that. Just call it 41.8. That's not an answer. Just because the calculator gave it to you does not mean it's an answer. We have to figure out where the sign is negative, which is down here and down here. So 41.8 is not those answers. So we have to do 180 plus the angle and 360 minus that angle. So minus that 41.8. So we get 221.8 degrees and 318.2 degrees. Now we have law sines and cosines. That's the only thing we have left. You will be given those formulas. I would like to know, so I would like to see the numbers that you use. Obviously, I don't need to see the decimals or the actual calculations, but let me show you what I mean. So this one, we are looking for AC. If you try to set up law of sines, it's not going to work, which means this is law of cosines. Or the better way, the more efficient way to do is realize that this is side angle side. This was the information you were given. Side angle side, and side angle side is law of cosines. Side 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 is also law of cosines. Or you could do the trial and error if you'd like. So x squared, and then we doesn't matter which one we use first, 8 or 9, we have to square them both and add them. Minus 2 times, again, those same two numbers. And then you go across the triangle. So this is going to be the cosine of 76. When you type this in the calculator, type the square root first. You don't need to do anything extra. You type it in exactly the way this is written here. Make sure your calculator's in degrees, but we just did a whole bunch of degree problems, so it probably still is. And then round to the nearest tenth, and we'll call this 10.5. So you can tell by reading this question, it says to find all the possibilities. This is law of sines. It's only law of sines that creates more than one answer. Law of cosines doesn't do that. So I'm going to draw this triangle, and I'm just going to label it kind of randomly D, E, F. You can't really label the triangle wrong. I'm going to also put in my numbers because that helps me. DE is 17. EF is 16. And we're looking for angle F. And this is across from the 17, so we can use law of sines right away. So we're going to have the sine of 47 over 16. Right? That's this relationship right here. Law of sines is across always. And then this is going to equal the sine of F, which we don't know, over 17. Cross multiply, start in this direction first, divide by the 16, and then you're going to do second sine, second answer. And then that'll spit out 51 degrees. Now we also have to check to see if we could have more than one answer. So then you do 180 minus 51. We want to check its supplement. So that's 129 degrees. Then we just basically have to check, do we have enough degrees, I guess we'll call that, do we have enough angles, angle measures to make this work? So we know that angle D is 47. That cannot change. The question is, do you have enough left over to create an angle E? So you're going to do 180 minus all these angles just to figure out if you have enough room in your triangle. So this one, it does work. You get 82. So this one definitely works. And then angle E here actually it still works. It's small, but it still works. So we have two different answers for this triangle. That's why it says to give all the possibilities. So angle F has two different possibilities. The angle that you're given can never change. So that angle that you're given will not ever have more than one answer. It's the other two that change. So here we have a nice picture. We're trying to find the distance. It says two other points P and Q and the measures of the angles from P and Q to the reference line. Oh, we're given all that. Find QR. All right, so we're going to find this. Right here. Best way to do this, we have a lot of angles. Let's just find all the angles and see if that helps us. If you don't understand what the picture or the words are saying, it's really okay because they gave us a picture. This is a right triangle right here. All right, so this is a right triangle. So this angle is 68. I'm really trying to get to this angle right here. That's my goal because that's across from my X. Then, of course, we have this right triangle right here. And so this will be 55 degrees. These three angles form a straight line. So 180 minus 55 minus 68 means that this is a 57-degree angle. And that's all I need. So now we're ready to go. So we know that this is the relationship, so it's going to start with x squared. The other two sides, we don't really care about which order you do that in, so it's 148 squared plus 215 minus 2 times 148 times 215, and then of course we finish up by multiplying by the cosine of that angle we just found, 57. So this is just like problem number 15, and then you put this radical sign around the whole thing, both sides. We don't want the plus or minus answer because this is a length, and lengths are positive. So put that in the calculator, square root first, 148 squared, 215 squared. You can use parentheses for your multiplication if you want, cosine of 57, and we get 182.9, and this is, of course, meters. So that problem, they gave you the picture, and the picture was nice. We didn't really have to read the words. Now the picture is maybe going to be a little bit more of a problem. So we're trying to find the width of this river, and you can see they gave you a nice question mark right here. So we're trying to find this. All right, so I'm assuming that this is still the river over here. So we have P and Q, and they're 280 feet apart. So there's some sort of tree over here, and the angles are marked. How wide is the river? Okay. So we have to find that. I'm going to redraw this triangle because it's hard for me to look at all those things in there. We just have a regular old triangle. This is 48. This is 280. And this is 52 degrees. So we could easily find this angle right here. 180 minus those two, that's going to be an 80-degree angle. So I can use law of sines. I'm going to find this side. It doesn't really matter which side you find. I'm just picking on that side for whatever reason. So I know I have the sine of 80 over 280. That's the one I have to use because I have both parts. The one I want is I'm missing this side, and I'm going to use its angle, sine of 52. Now, in a story problem like this, you're not going to have to figure out if there's more than one answer. All right, so that you don't have to worry about that. We start on this diagonal, then you divide by the sine of 80. This is not an angle. This is whatever the answer is from the calculator is what you want. So I have this, 224 point, let's call it 1. And I put this one right here, 224.1. This is a right angle. I'm going to redraw this triangle. This is 48 degrees. I'm looking for this. Ultimately, this is my question. I just figured this out, 224.1. Do not call this 140. You don't know that. So I'm just going to do, you can do law sines, right? Because we know the sine of 90 over 224. I'm just going to do, this is opposite, this is hypotenuse. I'm going to use plain old sine. Sine of 48 is equal to x over 224.1. It's a right triangle, might as well. You put that in the calculator, and you get 166.5 feet. If you'd rather use law of sines, it would look like this. Sine of 90 over 224.1 equals the sine of 48 over x. And you can certainly do the law of sines there as well. But that's the final answer.